morning or afternoon, whatever it is, ladies and gentlemen, here in New York City. Good morning, good afternoon, good evening if you're actually watching this on the on-demand edition that we will produce of this keynote on the World Wide Web. Thank you all for joining us. Sorry that it's not just cloudy this week, but also rainy. I'm not in control of the second part, but I can help with the first part, and it's great to see so many hundreds of people crammed into here. This, according to VMware CEO Pat Gelsinger, I'm sure you've heard this, I've been bombarding you with it all week. This is the fifth wave of change in the IT industry. I mean, we can do all the terminology of what they're called, but Pat, he likes the mainframe era as number one, and what he calls the mini computer era as number two, and then he says there's the PC era, that makes sense, and then he says there's the internet era, which he thinks has ended, which puzzles me, but that makes cloud computing the fifth wave. And the reason you're all sitting here, I'm guessing, is what Pat Gelsinger says next. Firms must ride it or be swept away. So that's the decision you guys are going to have to make. To help you, right from the get-go, we have Dr. Daniel Sabbah, who is newly appointed as the CTO and General Manager of this wonderfully named Next Generation Platform Group at IBM. So I'm not going to steal from his time, because I've seen some of these slides, and they are good. So let's give it up, please, for Danny Sabbah, and let's start Cloud Expo New York. Thank you, Danny.
So I'll add my hellos. Interesting room. In any case, I'm going to try and spend a few minutes with you today and give you a sense of what we mean by next generation platforms, what we mean by the transformation and the inflection points that are going on in the industry today, and how we're dealing with them in one way or another. So I'm going to be talking mostly about what we see. And before I really start talking about cloud, I'd like to spend a bit of time setting a broader context, if you will, because a lot of this fifth, whatever it is, fifth generation, if you will, really comes from the evolution of what we think of, and frankly, a term that was coined by Xerox PARC quite some time ago called ubiquitous computing, or pervasive computing, if you want to think of it that way. We were talking about pervasive computing about 12, 13 years ago. And the advent and broad communication that we see around the internet. We've created extensive opportunities in almost every single major industry. And these opportunities are really being exploded between what we think of as handheld mobile computing, as well as another thing that I think people refer to as the Internet of Things, or embedded computing. Always on, always connected, and always connected on the internet, which is one of the key elements of what we'll be talking about today. Not only that, but basically it's giving us spatial and temporal information as it goes. So we're now gathering huge amounts of real-time, potentially, and I'll focus on that particular word, potentially useful data. Here, what I've done is actually given you about 6 examples of people that have tried to make sense of that potentially useful data. It's giving rise to many, many new applications. These examples we all know about and hear about every day normally are from applications that you think of mostly as consumer or retail applications. Finding your favorite restaurant, then getting directions to that particular place dynamically from where you are. Being offered a coupon or an incentive as you get your morning coffee with the emergence of things called mobile wallets. But there are many more examples in travel and transportation, in healthcare, in pharmaceuticals, just like the ones that we have here, just-in-time maintenance, like the one that we also have here, and what we've been talking about and referring to over time that we call smarter cities, with things like just-in-time traffic integrated with dynamic rerouting and many different types of governmental applications in addition to industrial applications. But if we stick with somewhat simpler, more mundane applications, and we think of, for example, embedded intelligence that constantly reports back, say something really simple like the bending of rails as you go down on a high-speed train being fed back continuously through embedded intelligence in the wheels. Rather interesting application, generating lots of real-time data, right? And generating the ability to actually monitor and understand how you might, do just-in-time maintenance on mundane things like railroad tracks and keep high-speed transportation systems moving. However, in addition to that kind of a simple application, just think of your car in 2015. How much compute power do you think will be in your car in 2015? 64-bit processors, lots of them, that basically will be monitoring and managing a data center on wheels, connected through LTE, back to much larger data centers, all trying to integrate information simultaneously. So there's lots of examples. It doesn't just have to come through social analytics. It doesn't just have to come through MapReduce algorithms that are being generated through Google and Google Analytics. It doesn't just come through Facebook or Twitter or any of those things. It's actually coming at us from many different angles. One of the interesting aspects of this is that periodically what we do is we look at not only the information that we get, but what you do with that particular information, including generating new business models. So for example, one of the things that we saw in that previous example that I call just-in-time maintenance is actually leading to new emerging business models. And those business models are doing things like, instead of selling large CapEx, jet engines, what you actually do is rent them. And that rental is an entity that's actually being managed in real time, because there's embedded information being broadcast in real time all the time while planes are actually flying. And that rental model takes out CapEx, replaces it with operational expense, or OpEx, and makes it much easier for airlines to actually consume large jet engines on a real-time basis and manage them, once again, just in time. So all of this big data is not only leading to tremendous amounts of information, but also to rapidly emerging, completely new business models. And it's impacting not only those particular industries, but it's also impacting our industry. So if we take a look at what we see as shifting models around that particular big data, remember, it's continuous, it's real time, and it can lead to context-aware information that is both spatial and temporal. That information can be analyzed and can lead to entirely new classes of applications, so-called innovation. That innovation, basically, is what's driving a lot of what we think of as cloud and the emergence and evolution of cloud. So those entirely new classes of applications move from simple search to analytics, or what people refer to as analytics, and eventually they move into a realm of learning applications, especially if they're getting continuous feedback. and if the analytics are changing and evolving and becoming more predictive over time. So that whole notion of these new classes of applications with interconnected solutions is giving rise to what we call new era analytics. Those new era analytics behind tremendous amounts of innovation is really what's driving what we think of as systems of engagement. With these systems of engagement, given that continuous real-time spatial and temporal information, what we're starting to see emerge, basically, is this whole notion of next-generation architectures, fundamentally based on what we think of as clouds. It's not necessarily supplanting all of the old legacy applications. What we're seeing largely is that it's extending those particular applications. It's extending the systems of record that we think of every single day as managing transactions, managing your bank records, managing all of that governed and all of that compliance-based data that needs to be secure, needs to be behind data center walls, so on and so forth. But all of that big data and all of that information that's coming out of these mobile and embedded devices is really starting to mesh with and allow us to create brand new applications in almost every single industry. Now, as we go through this, I'm going to talk about three core concepts. One is that applications, especially around systems of engagement and what we're now calling systems of interaction, are applications that really move to execute directly on the internet. Really interesting concept there. Not only that, but given the fact that all of this data is largely noise when it first comes in, it requires that not only does it have to run on the internet, but that you have to iterate very quickly. And it forces a particular perspective that we refer to as continuous delivery, which means that this notion of what I do as a developer, to discriminate what I do in operations and in execution of what I do as a developer, that particular gap, wall, whatever you want to call it, has to come down. And this notion of continuous delivery means that the development environment that I use had better map directly into the execution environment that I use so that basically I can get that feedback loop going and I can get rapid experimentation going very quickly. Now, another element that's going to come out in our discussion today is something that we'll refer to as the API economy. Each one of these elements that come into play that run on the internet is going to have a set of APIs. Those APIs manifested in RESTful basic representations on the internet are now starting to be woven together dynamically. So the whole notion of dynamic composition of RESTful APIs is also starting to become quite dominant in this particular world. So applications running on the internet, continuous delivery, and API economies are crucial to everything that we're going to talk about. Now, if we step back to reality for a second, one of the challenges that we all have in today's world is the fact that we've already spent a lot of money. And not, I mean, if you work within the confines of a more traditional data center, basically, your budgets aren't going up a lot every year, if they're going up at all. And in many cases, basically, they're going down. So the reality is that in order to be able to actually tap into all of this innovation, tap into all of this data, run all these types of experiments, we all have to deal with the reality of optimizing the resources we currently have so we can free up money and we can free up equipment in order to be able to run these types of rapid experiments. So what you'll see is everything that we're trying to do is to try and help with that overall balance between consolidation on the left-hand side and optimization of innovation on the right-hand side. So if we take a look at classic examples of this, essentially, when you have these massive amounts of data and the volumes keep on going up, in many cases, there are pragmatic issues, like, for example, many of the costs associated with that particular data start to become unaffordable. So there have to be solutions that not only allow you to consolidate around virtual machines, which is kind of the classic notion of consolidation, but also has to help you consolidate and reorganize and understand exactly what's happening with all of that data. How much of it is ephemeral? How much of it is really associated with transactions and records that have to be managed and kept? How much of it can be thrown away? All of these classes of problems start to emerge in all of these different contexts. Not only that, but basically the new solutions have to take into account this whole notion of continuous delivery, this API economy, so on and so forth. So the way that we've started thinking about it is we've organized it into 3 core elements. What we call a software-defined environment, what we call a cloud operating environment, and that notion of APIs being woven and composed together into an API economy. So I'm going to talk a lot about each one of those particular elements in the time that we have remaining. The software-defined environment really is an element that we think of as focusing on operational costs. Those particular operational costs are around what I talked about before, around consolidation of both solutions and infrastructure. But probably more important is the fact that it focuses on operations automation. Automation is absolutely crucial to not only the consolidation side of this, but the DevOps side that you'll see on innovation. So standards, normalization, and standardization is absolutely crucial to being effective with automation. So we'll talk a little bit about that on the software-defined environment. On the innovation side, basically, the focus is really a lot more on speed and agility, as I said before. So assembly of components as core services running on zones on the internet or clouds, whatever you want to call them, basically, is crucial to that particular aspect of things. Now, one of the things that we noticed last year was we'd been using this particular graphic to correspond to what we think of as our IBM Smart Cloud. When you think about the dynamic nature of what we just started to introduce, it seems kind of static. And frankly, doesn't necessarily address all of the dynamism, especially around continuous delivery that we've been talking about. So in large part, what we've started to do is break it down and start to fill it in with the dynamic nature. Whoops, there we go. With the dynamic nature of what I refer to as the software-defined environment at the lowest level, at least at the infrastructure as a service level. What we're talking about here is essentially 3 core elements, all based on standards. Remember what I said? Standards are key. A lot of the way that standards are manifested in the industry today is not in dry old books, but largely in open source initiatives that are supported by many different vendors. And so one of the things that we did very recently, frankly, about 4 or 5 months ago, is we decided to start focusing on one class of standard around software-defined compute, software-defined networking, and software-defined storage, coming together and providing an abstraction layer of services that can be virtualized. Doesn't have to be virtualized. It can be virtualized. We call that OpenStack. That's not something that we called, but basically that the community has rallied around and started to focus on and work on together in open source around that kind of standard. Now, we have also done something in the software-defined networking arena called Open Daylight. And that's another open source-based standard to try and normalize networking and basically try and get a sense of exactly what it means to define and open up a controller to software-defined networks. So we're continuing down that particular path. I'm not going to talk about every single one of these standards, but basically there's a couple more that are really important. One is a linked data standard called OSLC, Open Services for Lifecycle Collaboration. And the reason why it's so important is as you get into these types of dynamic environments where a lot of what you're trying to do is compose clouds and cloud-based services, trying to understand what's going on in that particular composition and link it together to get a better sense of that continuous delivery loop is extremely important, and that's what OSLC is about. That's been going into OASIS as well as W3C. And so one of the elements of what we're doing with clouds in that dynamic nature is pushing that particular set of standards. Now, in addition to understanding exactly what's going on, workload characterization is key as well. Because as we develop cloud-based workloads, understanding how to optimize those particular cloud-based workloads, no matter what they're running on, is extremely important in being able to do that consolidation and optimization side. So you're making best use of your underlying resources. Remember, that's absolutely key to some of the cloud economics that we're talking about. So in that software-defined environment, what we've started doing is actually building languages, pattern-based languages, as well as just real languages that basically start to define workloads, characterize the resources necessary on top of software-defined environments to actually represent and abstract those particular workloads so we can actually compile them down in the context of a cloud around workload and workload-based resources. Okay? One of the reasons why OpenStack is so important is because it provides that layer of abstraction and isolation so you can do that kind of compilation, if you will, in the context of a software-defined environment. That's absolutely crucial. However, you need to be able to represent those particular workloads in ways that everyone will understand, which is one of the reasons why that pattern language is actually being evolved and communicated through OASIS, not through IBM, through Tosca, which is a standard in OASIS that's shared by everyone. So once again, this notion of orchestration, optimization, and workload definition is being done in the context of not just an IBM-based cloud, but interoperable clouds that come through everyone in this particular industry. So you have workload definition, you have orchestration, and that orchestration can map to fairly popular tools like Chef, and then can lead to optimization if you have a feedback loop in there that tells you exactly what's happening through monitoring. So that notion of a software-defined environment really leads to a programmable, shared infrastructure that through analytics, once again, but this is IT analytics, not domain-specific analytics, can actually lead to much better utilization of the underlying resources that you have as long as you have that workload definition and you can manipulate through software-defined networks, software-defined compute and software-defined storage. So great example of that kind of continuous evolution being applied to IT itself as a domain and as an industry. So now, on top of that, basically, what we start to do is we start to see the emergence of a developer-centric platform. And that developer-centric platform really consists of a whole marketplace of services in what we call a cloud operating environment. And it's really the elements that would normally manifest themselves in what you think of as a platform as a service. So whether or not you're looking for mobile services, whether or not you're looking for data and data persistence services, that particular layer or transactions or messaging or whatever for creating new applications starts to manifest itself in this, frankly, set of APIs, set of services that in a cloud context can actually run on that software-defined environment and will allow you through that continuous delivery model to create and deploy and manage entirely new applications very rapidly through agile models. Now, I keep on using this notion of a service. What does it mean? Well, a traditional software package normally requires that we do things like installation, configuration. We actually have to provision hardware on which it needs to run. One of the beauties of a cloud-based environment with a continuous delivery model is the fact that you can actually define a data service or a transaction service or a messaging service. And when I use that word service, what it means is that the installation, core configuration, infrastructure management, scaling, performance, maintenance, all of that comes as an integral part of that underlying service that you can actually purchase or use regardless, and somebody else manages that. So all of these services that we're talking about in this compositional layer are really manifested in this particular manner. And that manner makes it significantly easier to then use that service and not worry about where it's running, what it's doing, whether or not it has to be provisioned with hardware, underlying storage, or networking. Remember, it's on a software-defined environment. So that level of standardization allows you to go through this kind of very fast iterative model that says, I create an app, I add a database service, I extend to social media as a service, basically. I add an analytics service. I secure that particular service. Someone else is dealing with all of the complexity behind it. And then I may add monitoring in a given instance. And if I actually manage that in the creation of that particular service and I define it through an extensive lifecycle model where I know exactly where those services are coming from, how they're created, how they're managed through standards, once again, linked data, internet, right? These applications run on the internet through W3C or Oasis. I get those particular patterns. I know how those particular patterns come together. I get that definition, basically. The administration of that kind of a standard or the composition of those standards becomes possible. Notice I didn't say easy. I said possible, okay? Because once you actually play with these things and you start to create somewhat recursive or complex applications, not so easy, okay? So there's no magic here, folks. It's just the evolution of something that we're trying to do that makes it absolutely crucial to those types of systems of interaction or systems of engagement to create brand new types of applications. However, if you have an underlying series of services that themselves are composable and integratable into your applications like monitoring, usage and accounting, event management, backup and restore. And they're independent of any given or single cloud. And they manage to, once again, using internet and internet-based standards to give you events that are independent of clouds. You can actually start to think about integrating and creating applications no matter which cloud that service may actually run or reside on. So that's one of the core elements that we're also providing in our approach to building out clouds. So to get back to this whole notion of an API economy, if you have these services, if you start to surface these services, and you actually want to build new applications either from pre-composed services or ones that you create yourself, it starts to speak to what we think of as a service fabric. And that service fabric has to actually come together in a consistent way so that basically, as you start to think about building a new commerce application, a new mobile commerce application, a new social mobile commerce application around banking or telco or retail, you can actually start to compose these particular services that are cloud deployed, that you don't have to manage, and that you can actually weave together into a new set of services. It goes a little bit beyond what you used to think of as mashups. But one of the core principles here that's starting to reassert itself is what we think of as service-oriented architectures. Because these types of service-oriented architectures built on pure internet standards, not web services with SOAP, not BPEL, okay, for those of you who played with previous generations of service-oriented architectures, but purely based on RESTful APIs and protocols that are exchanged with languages like XML that are rich in semantics, will actually allow you to start weaving together these types of applications and generate new solutions very quickly, and generate the types of experimentation that you can actually manifest in front of a customer or a consumer very quickly. So that notion of an API economy, once again, is not just a set of services delivered from a single cloud, but is a set of services that can be delivered from anyone, running anywhere, geographically, or on any kind of physical infrastructure. But that physical infrastructure has to be able to describe itself and has to be able, through those particular types of standards, has to be able to deliver things like quality of service, has to be able to deliver things like SLAs, and those SLAs have to be incorporated into an understanding of what the delivered application, now composed of all of these services, is actually going to manifest. And if you're doing anything around marketing or marketing class applications, we've already talked to a lot of customers who are struggling with that particular aspect of it. Because even if you have 99 or 97 or whatever it is, SLAs, 97% uptime, when you start composing those 4 or 5 at a time, all of a sudden the combined probability of reliability or uptime starts to decrease pretty dramatically. Remember, it's a progression, mean time between failure, all of those things. So understanding that kind of composed aspect of cloud-related services is another thing that we're focusing on in that whole notion of lifecycle manifestation. But nevertheless, basically, regardless of whether or not it actually gives you 60% uptime, people are forcing that kind of evolution because of the value and the innovation they think it's going to get. They're going to get out of those new types of applications. Okay? So we're not going backwards. So when you start to put all of this together, And you start to look at that whole notion of a software-defined environment on top of a cloud operating system, as well as putting together an API economy. It's actually a lot richer than this, because that API economy comes from pretty much everywhere. It's not a single cloud. It's not the single definition of a single cloud. It's multiple clouds that start getting woven together into a whole new view of evolving business processes, as well as evolving data integration tasks, coming together in a much more dynamic environment, one that has to actually be managed through internet-based standards. So if you take a look at that and we suck out that particular notion of a cloud operating environment, what we're actually doing is literally building out one of these. We're putting in development services, we're putting in data services, persistence services, storage, underlying compute, network and network management, everything that you need in order to be able to actually build one of these. And we're doing it on open standards, because we don't think that it's about a single cloud. We think it's about an open ecosystem that actually has to manage these types and integrate these types of applications. And by the way, we also don't think it's about just new applications. We realize that many of you have existing applications that need bridges back to this kind of newly evolving world. So what we're trying to do is a little bit more general, takes a little bit more pain, because frankly, when you think about trying to establish all of the standards necessary to be able to manage this kind of heterogeneous open ecosystem, it's a little bit more difficult than just setting up a set of your own services and allowing those particular services to work within that particular closed ecosystem. But we've been around a long time, and we know that for large classes of our customers, having this kind of an ecosystem, an open one, is absolutely crucial. So we're actually building this out. We've got a word for it. We call it Blue Mix. Unfortunately, it's not completely open to beta right now, but we just did an internal hackathon on it, and we brought up about 600 applications using about 500 or so people banging against it, so that basically we could get a sense of what resilience that particular environment had and whether or not we could actually get useful applications out of it. So we're evolving it. We're using that same model of continuous delivery. We're using that same model of integrating not just IBM-based services, but ones that have become popular, like MongoDB, into that particular environment, so that people can actually build out large classes of applications regardless of where the services themselves come from, and can actually start to think about managing it. So once again, these are the core elements. Remember, applications running on the internet based on open standards, continuous delivery, and that notion of the API economy. A much more dynamic view than what we saw originally as SaaS, PaaS, and IaaS. That's where we see the evolution of the drivers that are forcing these notions of systems of engagement as opposed to systems of record that then generate systems of interaction. And once again, based on open standards to create those types of ecosystems. Thank you very much for your time and attention, and I hope we can work together at some point. Thank you.
Thank you. Thank you very much, Danny. We do have time for questions. I'm actually do it from the stage. That's the only way I could see you. If anyone has a question, can they please show me their hand, and I will come racing to you with a microphone. I promise you. This guy is waving his hand, which is hopeless. You have to be very, very, very careful, you see? Come along. Who's got the chance to ask IBM's CTO of next generation? Ah, the lights are up. Here comes a hand. Here we go. One for you. Mic 2, that is. It's live. What happened?
Yeah, what's the, where does the recent acquisition of software fits into this picture?
I'm sorry, what?
Where is the recent acquisition of SoftLayer?
Of SoftLayer?
Yeah.
Yeah. So SoftLayer basically has some rather interesting characteristics. They have an OSS and a BSS layer with a whole series of APIs, about 2,000 APIs or so, that are at the core of managing that OSS and BSS interaction. And they've done actually a very good job of managing what we call cloud economics, which is understanding the relationship of the services that they actually support, which, by the way, most of those services don't actually run on virtual environments. It runs on provisioning of bare metal. And that provisioning of bare metal is actually directly related to what they do with their OSS layer and their BSS layer. In other words, what they charge people and how they actually drive those particular economics to the ground, okay? So in many ways, you can think of that 2,000 set of APIs and their flexible network, because they have a relatively primitive SDN already, as a way of thinking about that kind of software-defined environment. And that's one of the reasons why we thought it was actually quite attractive as a property, because of that degree of flexibility and that degree of mapping to performance and that degree of actually doing provisioning of bare metal targeted towards specific workloads and classes of applications. I'm sorry?
Will it support OpenStack?
Yes, it will support OpenStack. It does not support OpenStack today. The virtualization layer that they use today is actually based on a joint effort that they did with Citrix based on CloudStack, okay? But all of what you saw in Bluemix is actually based on OpenStack, and that will be running as a region in SoftLayer.
Excellent answers. Another question here.
Yeah.
What do you see as the adoption process, not only by companies like IBM that are going to provide this, but by the actual end users? And do you see it going from the enterprise to the small, medium business class?
Yeah. So one of the really challenging aspects of what we tend to do, especially with enterprises, is that whole maturity model, the evolution of a maturity model, where people start with consolidation, usually, around virtualization, and try and at least stabilize their existing environments. However, one of the realities that we always see is the fact that over time, there's been an aggregation of point solutions based on individual applications that have grown their own individual infrastructure. And at the time, it seemed like a great thing because it gave you time to market and speed and everything else. But then what happens is over time, you start to aggregate all of those things and then trying to build out a common view of visibility, control, and automation to enable a cloud becomes much more difficult. So we have maturation, we have types of services for doing migration, for analyzing which applications you might want to move into this particular world and which ones you might want to just leave alone. And you can go through that kind of maturation service basically and at least isolate those things that you can move into a cloud world, and then analyze what you can move into a private cloud world versus what you can actually move into a more public cloud world. So there's the applications you want to leave alone. There's the applications that can be normalized in some way and can run on a private cloud. And then there's the class of applications that you can actually run on a public cloud. And sometimes those particular workloads will actually split applications. So there are some applications that will run partially on a public cloud and some that will run on a private cloud. We call those hybrid environments, as I'm sure you're well aware of. Okay.
Another great answer, another great question. Two more questions coming up. Number one, sir.
Thanks for the presentation, Danny. I'm Setu Arande with Arande Media. I'd like to know how the smart cloud strategy in passing video, communicating with video.
Yeah, actually we partner on video services around smart cloud today. So we don't, strangely enough, when I spent about 11 years of my career in IBM's research division quite a while ago. And we were actually building out video services back before anything like Netflix had manifested itself. And we literally had video servers, something like 14, 15, 16 years ago. Unfortunately, like many inventions, they didn't necessarily turn into innovations, where those particular innovations or the infrastructure for that particular invention was market ready, right? Big difference between something you invent and something where the market is actually able to consume it. So from a video service perspective, we have not matured those particular services, although we will be bringing them in to something like a Bluemix, but that's one of the reasons why we keep it open, okay? Is because we can't build everything, frankly, and we can't be experts on everything. So we have to keep our environments open, and we have to keep them accessible.
And the final question comes from an old Cloud Expo friend, Andy Schreckfer. Well, you probably can't see him. He's behind the pillar.
This will be my first time seeing the speaker. This will be great. Hi, Danny. It's Andy Schreckfer from Big Cloud Sales.
Sorry, I can't see you.
Hello. Since
Maybe
you
if I
obviously
walk-
didn't choose Rackspace, the question you probably can't answer is why not? But more directly and broadly to the community of people that run an OpenStack cloud, is IBM's intention to make its OpenStack platform such that a customer could have a hybrid environment between IBM and a Rackspace or others? And
Yes.
what limitations might be there that would be a more interesting answer?
Well, I mean, let me be clear, very clear, okay? Our commitment is to OpenStack, period, okay? There's no ifs, ands, or buts on that particular front. The fact that, in this particular case, SoftLayer has and will have existing customers that are running CloudStack doesn't confuse anyone internally in IBM, okay? We are committed to that. For all the reasons that I gave you in the whole presentation, we are committed to an OpenStack-centric evolution of all of our cloud services, okay? And we'll do whatever we have to in order to be able to interoperate with anything else.
Thank you.
Yep.
Thank you, Danny. Thank you, audience, for your questions. That, as ever, will be a theme of this week. Danny Sabbah from IBM. We have a quick change. Please don't leave your